right, so we're going to talk about something called a residual today. And what's a residual? Isn't that like the goo that's left over after you take a bath? The stuff
Yeah.
that's like on the side of the tub?
It is. Ew, gross.
You know, like the gooey soap scum or bubble bath or whatever. I don't know.
You're disgusting.
They like make it sound like it's the worst thing in the world in those bathroom cleaning commercials. So no, that's not what it means. But it does
Residue.
it actually does kind of connect to it. And I'm sorry, I'm quite literal. I guess you kind of figured it out. When I see a new word, I have to try to make sense of it. And
Yeah.
residual, just like that's the only framework. Yeah, it's the residual stuff that's after something. It's the leftovers.
Yes.
Okay.
And in statistics, it is actually the leftovers.
Yep, it is the same thing.
It
It's
is.
a good word.
Yep. Okay, so a residual is the difference between the actual data point and its predicted value from the regression line.
This is why we make such a big deal about it in statistics. We know we're not going to hit every point. It's not possible to hit actually every point when you're running a regression or you're trying to find the linear model because the data is not perfectly linear. It's an approximation, and we're going to accept certain errors or certain leftovers to our estimate. And that's what we call it. How far we're off from the actual value is what we call a residual.
Right. So what we can do is we can take all of our true data, type it all into our equation, right, and get all predicted data, and then we can subtract all of our actual data minus our predicted data. And the way that you remember this, like the order that you subtract them, is you're in an AP class, you do actual minus predicted, AP, A minus P.
I always got that backwards. That's great. That'll help me. Thank you.
Okay, so a residual plot is when we take all those residual values that we found and we plot them. So we're going to look at what that looks like.
So we know we're gonna have mistakes. We just accept that the world is icky and we know we're gonna have mistakes. We want to try to minimize our mistakes. That's the whole point of this. Okay. So when we try if we see some things in that plot of our errors, then we know we can do better. And we'll talk about that.
Right. And then we can do a couple of things. We can look at the residual plot to make a decision about the appropriateness of our model. Okay, so we'll kind of get to that later. So guess where I went to get data?
No, you probably went to the census again.
I did, but actually before we do the census, I just remember we got to talk about the trucks again.
Oh, you're talking about the trucks again.
Yeah. So here's the Ford trucks coming back. And hope that you watched the last video or this graph isn't going to mean anything to you. And so what we have here is a model for the Ford trucks and how much they're worth after they've been driven for a while, and then the actual data points that they grabbed, right?
Right. And remember, we said they didn't all hit, like, for example, I remember talking about these 2 points. Those points were above the line. I said those were like the fully loaded, heated seats, special trucks. The value of those trucks is actually greater than the model predicts.
Right.
I don't care why, but I want to know that I made a mistake, and how big a mistake.
Yep. And so what happens is we want to know how much too much, right? How much more is it in truth than it was in our model? And that amount, which in this case looks like it's about $7,000. So it looks like it's about 7,000 more than what I would have predicted. That 7,000 would be our residual.
Mm-hmm.
Now, it's a little tricky because that's above.
Okay.
Remember, we're going to do actual minus predicted.
Okay.
So if we do, let's say this one.
That's the one I was going to pick.
And we compare it to its prediction, which would be the same X value on the line. What does the residual look like in this case?
And that looks like it's about 7,000 below. So this would be minus 7,000.
Yeah.
Okay. The farther that point is away from the line, the bigger the error. Now, some points are going to be far away. Okay. Some are going to be close. I mean, like this guy down here, pretty close, spot on, not too far away. But still, it was a little bit above. So that one's going to have some small positive number. Okay.
Yeah. Now, what's happening when a computer or calculator or whatever generates this line is they're trying to get the same amount of error above the line as they're going to get below the line. They're trying to get in the middle so that you don't have too much error on the top and you don't have too much error on the bottom. In fact, if I were to add up all these residuals, all the negatives and all the positives together, I should get zero. I should get zero. And that tells me that I really am in the middle, right?
Mm-hmm.
If I'm directly between 7,000 above and 7,000 below, then I've got
what the difference is in a
yeah.
sense.
Yeah. Okay. How are we doing? We're doing good?
I think so.
All right. So now then let's go to the data that I grabbed. So I wanted to look at Arkansas occupation by sex and median earnings in the past 12 months.
And I even alluded to this. I didn't know she wrote this when we made the last video. I was like, oh yeah, we could look at sex versus income. In the back of your mind, you must have been laughing.
Oh, good idea, Mr. Bobby.
Yeah, you might have not noticed it by now, but Miss Young and I sometimes think alike.
Yes. So, the first thing that I was irritated by is
my space cat, my taco cat shirt.
Not your taco cat shirt.
Okay.
The fact that this overall, if you look at the male occupations, they're almost always more for the same exact job than the female, which we know, even though people don't want to admit it. So here's what it looks like. Here's your graph, and I gave you a few pointed out because I want to be able to look at our prediction line and our R value. So what do you think about the R value? Before I give it to you, Mr. Bobby, what do you think?
I'm unfortunately going to have to say looks like it's pretty good one. If I were going to draw this with a dog, put my dog over top of this, I wouldn't necessarily need my fat dog. Maybe these two up here, these guys up here might, make my dog have like ears or something.
Yes, true.
Generally, it's pretty good. So
yeah.
Or a pretty strong model, I would think.
Yeah.
We're not going to try to guess the R again because
We're not?
I don't want to be accused of cheating. You got mad at me last time we played Guess the R.
So my R value in this one is 0.80 or 847, 0.847. Would you call that a strong linear correlation?
That's a big wow.
Yeah, that is a strong correlation. For this to be me pulling real raw data off of the census, that R value being that high is not super normal.
Yeah, that's actually, that's an outstanding R value for the real world.
Yeah, not an outstanding piece of information in front of us.
No, but it's, remember what I said in the last video.
Yeah.
Gather the data and let it tell you a story.
That's right. And so if we were to talk about slope in this problem, Mr. Bobby, what do you think slope, this 1.2787 represents in this problem?
That's the male earnings to the female earnings.
And what does it tell you?
It tells me that I, on average, earn $1.27 for every dollar you earn. Now, that's not exactly true in our case, but it's for women and men, men earn almost $1.28 for every dollar that a woman earns. And you hear that on, if you listen to these stories about stuff like this, you will hear it. And this is exactly what is the root of lawsuits. And there's a lot of, I mean, this is the kind of evidence that actually would be presented in the court of law for a woman trying to bring a fairness suit. And that this does happen in reality. And Walmart just got sued for this.
Yep. So now everything we look at is going to be based off of the understanding that men make more than women by and large. Okay. So then there are data points that are either above that or below that. Okay. And so I grabbed a few of them so we can talk about residuals in this case. You can see this to the bottom left-hand corner that that is a case where, what do we have? Females make 17,500, males make 12,299. So here's a case where the women are making more than the men. And then if we jump all the way up to that top right-hand corner, this is health diagnosing and treating practitioners and other technical occupations. So here is one where what the male is making is substantially different, yeah, that's right, than what the female is making, okay? So when we begin looking at residuals, what we're doing is we're saying, okay, right here at 17,541, our actual data point is that you can see it there on the right, 17.5 and 12.3. If you look at what we would predict for it to be, right, so that's this point right here on that vertical line, you know, according to our model, even assuming the males make more, we would have expected males to make,
24,000-ish.
Yeah, but they only make 12.3.
Yeah, so it's about, that case would have a negative residual, and I'm guessing at about negative 12,000.
Yeah.
Now that's, if you look at that job, service occupations, that's a low income job, and it's, so
yeah,
there's no why that is. I don't know. I'm not going to even speculate.
Good idea. So if we look at, let's say we look at the arts and design one, this one right here, arts, design, entertainment, sports, and media occupations.
I can't draw a residual on there.
Yeah. So this guy.
I'm zooming in, and I can't, maybe.
Yeah. Right here, it kind of hits the money for our model. Now, look, because this is an important note to make on this graph. On the line doesn't mean boys and girls are making the same amount of money. And I don't want you to think that's true, because look at that data point and how much more the males are making than the females. The line is assuming that average of the males making $1.25 for every $1 the female makes.
Oh, do we want to talk about the y-intercept at all?
We could.
By the way, just because it's not really, if the y-intercept was there, just for looking at the y-intercept there, what does that mean? That means if you were earning nothing,
you'd still be making.
I'd still be making $1,600.
Right. Ridiculous.
Okay. Now, I mean, we're kind of both passionate about this one. Okay.
Yes. In case you're wondering, Mr. Bobby does make more money than me, but the only reason he makes more money than me is because he has more years of experience.
Because I'm older.
Yeah.
And I'm going to die sooner.
Maybe. You don't know. I might die this afternoon.
Yeah, who knows? All right.
Okay, so let's talk about that residual. Now, there is a very specific way that you need to explain the residual. So we're going to go through a couple of examples of this so that I can make sure that your answers are spot on with the expectations. Okay, so Let's think about the health diagnosing and treating practitioners. Remember where that one was on the graph, Mr.
That
Bobby?
was the one that was way up to the right.
That's right.
That's right. That's kind of doctors and
Yeah.
medical, right?
So one thing that statisticians do that algebra people don't, and maybe it's boo on them and us because we also teach algebra, is instead of using X and Y, they'll use whole phrases. So you might see something like predicted male earnings is equal to 1612.52 plus 1.2787 times female earnings. Or you might not see the word predicted.
Mm-hmm.
You might see male earnings with the hat on it.
Where's my hat?
Here he goes again. There he is, the male earning with the hat on. That's actually what's happening right now.
Yeah,
you're earning your money, so you put a hat on.
And that's fine. Was it this class that we did the hat video?
I don't remember.
I don't remember. We did that for one of them. Anyway.
Okay, so here's what happens. We plug in how much the females make for that occupation.
For that occupation,
yes.
Right.
Females make $56,101 on average for that occupation. And we plug that in and we get $73,348.88 for our predicted male. So
on that equation.
Even assuming that males make $1.25-ish more, or not more, but $1.25 for every $1 that females earn, this is what they should be making. Was it? Does it fit the model? Well, no, we saw that.
We saw that big gap.
Because above, yeah, that's right. Above.
So we take the actual number, which was, I think, 106, right?
Yeah.
And subtract the number that Miss Young just generated. So the residual, the model didn't get us, and that was our error. The error, our model was off by $33,000 for this one.
Yep. Yep. So here is what you say. And this is important because you want to be able to explain things. The actual median income for males was $33,000. I should have put a dollar sign. I'm just really realizing that I didn't. $33,567.12 higher than the predicted for the health diagnosing and treating practitioners and other technical occupations when compared to females of the same field. So I used my residual number. I said higher. That word higher is super important. I was very specific about the one specific data point that I was using. I used the occupation, and I compared the two variables, males and females. Okay. Should we do that again?
I think so. And I'd like to do it for that one that was below, just so we can have a comparison.
Okay, good. How about
that's what you did anyway.
Personal care and service occupation.
Do I need my hat again?
So here's what we've got. Based on our earnings, or based on our model, predicted male earnings, same model. This time, this occupation, which was the personal care and service, our females earned on average $17,541. Oh my gosh, here we go. He's bored. I'm sorry. If he's bored, y'all are definitely bored, so I'm sorry.
I feel like I should be wearing a mask because I'm robbing you.
Oh my gosh. Okay, so here's what we get. We get $24,042. So if personal care fit the trend, the $1.25 trend, this is how much males would make, right? But their actual earning was $12,299. How do we find the residual?
We're in an AP class. So we take the actual amount, from the data, and subtract the one predicted by the equation. And in this case, we get negative 11,000. I estimated it at around 12 before. I was not bad, close.
Pretty close, yep. Okay, so now we need to write it in a sentence. So we're gonna say, the actual median income for males, I forgot the dollar sign on this one too, was $11,743.20 lower. So notice, and the last one I used higher because it was positive and above. This time it's negative and below, so I'm going to say lower than the predicted.
Don't put the negative on the number here.
Yep.
The negative is in that word, lower.
Mm-hmm. Predicted for the personal care and service occupations when compared to females of the same field. So notice again that I've mentioned both variables, the specific data for the data point, that residual itself, and whether it was higher or lower.
And you can actually see it. I mean, the number will come out, and you can just tell from the graph if you have the graph.
Yeah.
Assuming you have the graph. You may not. You may have just the data and the equation. You could do this even if all you had was the data and the equation.
Just remember that given your line, whether it's positive or negative, if the residual is positive, that means it was above the line. And if it's negative, that means it was below the line.
Right.
Yeah. Okay. So let's say we take all the residuals. So all I did was for you. So now let's assume that we do all these data points. Okay. So
and we calculate the prediction for every single X value and do all that subtraction for gosh knows how many points you have there.
Right. So let's see, we did a residual for this one and it was a really big positive number, like 33,000. So it's
that point there.
Yeah.
Oh, let's try to work together. You circle up top and I'll circle down bottom.
It's 33,000. If we go to our health occupation, we got like negative, I don't even remember when we just did it.
12,000-ish.
Yeah, negative 12,000. So you can see right here, it's at negative 12,000. So this right here is a plot of all those residuals. Mr. Bobby, why do they give us this horizontal line in the middle of the residuals?
That's the ones that hit right on. Like these guys right here are right here because they're the ones that were right on the line.
Yeah.
Okay, 0 is a comparison. And really, we don't, I mean, those values, that's not the x-axis below, okay, necessarily. It's kind of like a number line. But it tells me when I can reference when a point is actually on the predicted line, on the regression line.
Right. So here's why this is significant for us. Sometimes we get a model, we think it looks pretty good. We get an R value that we think looks pretty good. And we don't check the residuals. Well, we don't know if there was potentially a better model, right?
So what I think you're trying to say, or at least I'm going to try to make sense of what you're saying, is if the residuals, they tell me a story about my mistakes. And if my mistakes are consistent or show some kind of practice to them, then I know my model is flawed. Okay, so we're going to look at those residuals and see, is there some other underlying thing that maybe we've missed?
Right. So remember, we want an R value close to plus or minus 1, but that's not always or should never be the only number you use to determine if something is a good fit or not. Okay. And so if we have truly gotten a good fit, our residual graph will help us determine that. Okay. So let's clear that and let's look at something. This is median income in Arkansas since 2000. We've looked at this graph for the last 3 lessons. Every time we look at it, I give you a different piece. So the first time we looked at it, we did Duff's. And the second time we looked at it, we did this R value, and we decided the R value was maybe not super, right? Because it's pretty scattered over here. And so we said, that's probably a weak association. Then this last one, we started looking at the equation of it. So now I'm going to give you a residual plot. In the residual plot, what you are looking for is, do you see a pattern? And to me, Let me get my,
It's all over the place.
yeah, it's, you know, and we don't actually want a pattern. So it's so funny because you got all of these different things we look at in order to determine, is this a great model or not? So he just scribbled all over the place. What I do see is I'm primarily above, I'm primarily below, and then I'm all of a sudden primarily above again, meaning that the data points are kind of above and then kind of below and then kind of above again. So I could potentially get a higher R value by using maybe a quadratic model, right? A parabolic model rather than this linear model that I used.
It's not super stark, but it does like, yeah, there's, so my errors, I could see we were a bunch above. Now I had a couple points down here, but I had way more above than I did below at the beginning.
Yeah.
So
what we want to see is absolutely no pattern in the residual plot. We want to say, I see absolutely no pattern in the residual plot. I see a strong R value. I feel like a linear model is a good fit. That's what we want. And
again, remember, residuals are your errors. So you don't want any, or your mistakes, and you want your mistakes to be random.
Yes, that's perfect. Yeah.
Okay.
Okay. So
let's look at one that,
y'all, and sometimes I think y'all think that I search out for exactly what I want to happen. I'm literally thinking, what would be interesting to look at? What am I curious about? And I'm just grabbing data and then we're having conversations about it. That's actually what's happening. So the next thing that I grabbed, wow.
You skipped one.
There it is.
Yeah, okay, you had my order.
Yeah.
Okay.
So
this is a great one to talk about. And this is super scary in a lot of ways, not just
So mental health is always a huge conversation, but it's especially a huge conversation right now. So what I did is I grabbed the number of mental health disorders from 94 to 2016, and I threw them on a graph, and I made the residual plot and gave you an R value. So you want to talk about this, Mr. Bobby?
Yeah, I mean, when she showed it to me, and even she said she was shocked, this R value is insane. Like for something, so something's going on. Now, does that mean we have more diagnosis? People, I mean, are there more, we don't know why that's going up, but that's a very strong relationship. But she put a line on top of it. And when you look at this residual plot, if all you looked at was that R value, you would be like, woohoo, I got me a good.
Yeah, my model is good.
Yay, R value. But if I look at this, I clearly see something else going on.
Yes.
Okay. I mean, there's a very, very distinct pattern. So I'm still not sure. I mean, she didn't make this. No, she actually did get this data.
Yeah, no, I stole this off of the census.
Yeah, I can completely see a pattern to the residuals. So her model, and perhaps it's good that this is happening because if you notice, the pattern is actually, that the line would be predicting more in the future. Now, what troubles me about this is the data that she was able to gather ends at 2016, which I'm sure is only because what they have provided. And we all know that, this is continuing to go on and people are very stressed about what's been happening for this past year. So I'm afraid that it might actually go back up. So we don't know, and we wouldn't predict. Statisticians would, that's for the mental health or for the healthcare professionals to make decisions about and deal with what happens. Statisticians will look at this and say, this is not modeled by a linear function.
Right.
And then go on to something else.
Yeah.
Okay.
And there are other models you could look at. I think it's what would be, if we were to take off this part, we would think it's what's called logistic, where it's at some point you're going to not grow anymore. But then you've got this little piece where it looks like it's beginning to grow again. So you begin to think maybe that's cubic.
But all the statisticians would try to do. Now, there are statisticians who would try to find another model. In our course in AP statistics, we want to know, is it modeled by a line or is it not?
Yeah.
This is not modeled by line. Even though that R value is rock solid, this takes over.
Yeah.
Okay.
This residual model completely discounts your R value. It trumps it.
Yep. So even that's why this is such a great example. And I know you think she's setting this up, but you cannot just go by that R value. And you know what? Some of your teachers might think that too.
Yeah.
So,
yeah, that's, and I would be really honest to tell you, data science is very new. And when we all started teaching R values in Algebra 2, we would have gone strictly by an R value.
Yeah. I once had a couple of years ago, I had a college professor argue with me till tears. The woman was in tears because I told her R values is not all that we look at. And she completely got all upset and started crying on me.
Yep. All of the data science is so interesting because it's such a new thing.
Yeah, you have to look at as an entirety and let the data paint the picture for you. Clearly, there's something in that data that we don't know yet. I mean, that's not our point for right now, but it's just fascinating.
Yeah. So you can see here, I've given you a little bit of a kind of rundown on the things that we've talked about, how do you create predictions and being careful of extrapolation, how do you find a residual. I even give you a sentence frame for how to write your explanation if you need a sentence frame. This matches what you were seeing previously. And then when you look at a residual plot, you really want to see the scatter and no pattern rather than some pattern that's left over within the residual.
I don't know how y'all are taking notes, if you're doing it virtually or paper or you're printing and making notes, but this is a pretty good slide. I would capture these things if I were, however you're taking notes.
Okay, so you are moving on to, and I think this is the first time I've had you go to Desmos. You're going to student.desmos.com and entering in this code. If for some reason this code changes, I'll tell you on Google Classroom. I don't know if it expires, and I'm making this in July, so we'll see. The two Khan Academies and this picture, which is where I should have been 2 weeks ago, but couldn't go because Canada said no to Americans during this pandemic. But isn't it beautiful? Banff National Park. What were you saying?
No, I was gonna say I almost was there too. I got sent to Calgary by TI years ago.
You didn't go visit?
I did not go visit because it was too. I was sent there in February. You actually have to plug your car in. Like literally, when I rented my car, they handed me an extension cord, and when you pull up to the hotel, there were these poles where you plugged your car in because the oil would freeze. That's how cold it is there.
That is crazy.
Yes.
Okay. We will see you on the flip side, guys. Thanks for joining us. Bye.
Bye, y'all.